So the sample size required to estimate the population mean, mu, with a specified margin of error, e, is given by this formula. We have n equals z alpha over 2 times sigma star divided by e, and that whole quantity is squared. There are a couple of different things about this formula. For one thing, we have the sigma star. That's an estimate for the population standard deviation sigma. Because again, if we haven't yet selected our sample and gotten sample data, then we don't have a sample standard deviation. So this is just estimating the standard deviation however we can. The other thing that's interesting about this formula is that now we're using the standard normal distribution again instead of the t-distribution. Again, this is because without having already selected our sample, we don't know the sample size, which we need in order to use the t-distribution. So if we don't know the sample size, then we default to the standard normal distribution. Okay, so to get our estimate of our standard deviation, we can either use a value of s, which is the sample standard deviation from a prior study, or we can use what's called the range rule of thumb. This rule says that you can approximate the standard deviation by taking the range and dividing by 4. And there are a lot of situations where you can get a pretty good estimate or have a pretty good idea what the range of the data would be. And if you divide that by 4, that at least gives you some kind of estimate for the standard deviation. Okay, let's do an example of this. So back to the pennies. How large a sample would be required to estimate the mean weight of a penny manufactured after 1982 within 0.005 grams with 99% confidence? So what this is asking is what sample size would we have to have a margin of error of no more than 0.005 with a confidence level of 99%. So what we're going to use for this for our standard deviation estimate is the value of s that we had from the previous study in the previous example, which was 0.02 grams. So to use this formula, again, we're going to find a critical value, but this time it's going to be from the standard normal distribution. So our alpha is going to be 0.01, and that gives us a critical value of 2.576. Our standard deviation estimate is 0.02, and the margin of error we want is 0.005. Here you kind of have to read this into the problem because it just says within 0.005 grams. It doesn't say specifically that's what the margin of error is going to be, but that's what that means. So if we plug all this into the sample size formula, we get 106.2. Now, just like we did before, for sample size problems, we always have to round up to the next integer. So we would round this up to 107. And that means the minimum sample size we would need to get this margin of error and this level of confidence would be 107. Here's another example. For a particular model of automobile, a compact non-hybrid, a study is to be done on the miles per gallon. If a 97% confidence interval with a margin of error of 0.75 miles per gallon is desired, how many automobiles should be tested? So again, it's asking how many automobiles we want to test, which is asking what our sample size should be. And notice in this one, we don't have any information. We don't have a prior study on the MPG, so we don't have an estimate for the standard deviation. So we have to figure out how to get one. And to do this, we'll have to use an estimate based on the range and use that range rule of thumb that we talked about. So here If you think about it a little bit, you can make some estimates for the minimum and maximum MPG for a compact car. We could say that the minimum would be 23 and the maximum would be 33. Again, this is just an estimate, but at least you can have some idea of what those minimums and maximums would be. This would give us a range of 10, and then the range rule of thumb says that we can estimate the standard deviation by dividing the range by 4. So the estimate for our standard deviation would be 2.5. Now the critical value from the standard normal distribution for 97% confidence is 2.17. Now if we plug all that into our formula here, we end up with 52.3. One thing to notice here that's a little bit different than for our population proportion problems is that our margin of error is going to be just whatever it was given in the problem. We don't have to worry about converting percentages to decimals in this case. So our margin of error might be anything depending on what kind of problem we're talking about. At any rate, we get a value of 52.3 for our sample size. We're going to round that up to 53. So the minimum sample size we would need for this would be 53.